Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from z equal to x, y, phi of x plus 2y plus xz square by eliminating the arbitrary function phi. We are given a relation and we are asked to form a partial differential equation by eliminating this arbitrary function phi. So let's begin. Given z equal to xy into phi of x plus 2y plus xz square, right? Consider as some equation number 1, right? Here, now we'll partially differentiate it with respect to x and also with respect to y. Firstly, we'll partially differentiate with respect to x. While partially differentiating with respect to x, we'll treat y as constant, okay? Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1, or you can just skip this step and do directly. This gives us dou z by dou x equal to, here y is constant, right? So we'll write it as y into, or here you can also treat xy as u and phi as v, and you can apply u v whole prime formula, which is u prime v plus v prime u, right? But what I am doing is I am just taking this y constant, which is outside the derivative, okay? I am not taking xy as u and phi as v. I am just pulling it out. I am just pulling this y out so that I'll get partial derivative of x into phi of x plus 2y plus xz square. You can take it as u and this as v, okay? You can also apply uv whole prime formula for this, but for my convenience I'm taking this y outside, okay? Just pulling it out, and then if I pull this y out, I'll get dou by dou x of x into this phi, okay? Simple. Since we have a notation dou z by dou x equal to p, I'll replace it by p. We'll get p equal to y times partial derivative of uv, partial derivative of x into phi plus partial derivative of phi into u, okay? This gives us y into partial derivative of x with respect to x is 1 into phi of x plus 2y plus xz square plus partial derivative of phi of x plus 2y plus xz square is phi dash of x plus 2y plus xz square into inner derivative, that is dou by dou x of x plus 2y plus xz square into this x, right? Which gives us y times 1 into phi is phi of x plus 2y plus xz square plus phi dash of x plus 2y plus xz square into partial derivative of x, first term, right? Partial derivative of, here also you can just do directly. You can just skip this step and do directly into x. Right, now this gives us y times phi of x plus 2y plus xz square plus x into, or just let it be, phi dash of x plus 2y plus xz square into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0. Since we are differentiating with respect to x partially, so we'll treat y as constant. Here 2y is treated as constant, so the partial derivative of a constant with respect to x will be 0, right? Here you have x z square. Treat x as u and z square as v and apply u v whole prime formula, that is dou by dou x of x into z square plus dou by dou x of z square into x into this x. Clear, right? 1, 0 and derivative of this. Okay, this gives us p equal to y times phi of x plus 2y plus xz square plus phi dash of x plus 2y plus xz square into 1 plus partial derivative of x with respect to x is 1 into z square plus partial derivative of z square with respect to x is 2z into dou z by dou x into this x into this x, right? If you want, you can check it. Under square brackets, you'll have 1 plus 1 into z square plus 2z into dou z by dou x into x. Outside the square brackets, you'll get x, right? Fine. And this gives us y times phi of x plus 2y plus xz square plus phi dash of x plus 2y plus xz square into 1 plus 1 into z square plus 2z into, we have a notation dou z by, since dou z by dou x equal to p, just replace it by p, you'll get px into this x. Okay, which gives us y times phi of x plus 2y plus xz square plus x into y, xy phi dash of x plus 2y plus xz square into 1 plus z square plus 2xzp or 2pxz, whatever. Okay, clear, right? Y into x, xy, phi plus this term, right? Fine. Now we can just write this as, bring this term to LHS, we'll get p minus y into phi of x plus 2y plus xz square equal to xy into phi dash of x plus 2y plus xz square into 1 plus z square plus 2xzp, right? Fine. Now consider it as some equation number 2. This is 1, right? Now partially differentiate 1 with respect to y. Now let's partially differentiate 1 with respect to y. Okay. Partially differentiating one with respect to y. Just apply dou by dou y on both sides of 1. Here we are partially differentiating with respect to y, so we'll treat x as constant, right? So let's take pull this out. This gives us dou z by dou y equal to x into partial derivative of y into phi, that is phi of x plus 2y plus xz square. Since we have a notation dou z by dou y equal to q, Let's replace dou z by dou y by q. We'll get q equal to x times partial derivative of, here we are going to apply u v whole prime formula, which is u prime v plus v prime u, right? Fine, this gives us, just treat y as u and this phi as v and apply the formula. We'll get partial derivative of y into phi of x plus 2y plus xz square plus partial derivative of phi x plus 2y plus xz square into y, right? U dash v plus v dash u. This gives us q equal to, here also we can apply u v w whole prime formula, which is u prime v w plus v prime u w plus w prime u v. We can also apply this, okay? We can apply u v also. You can consider u as x, y and v as phi, and you can apply this formula, or you can apply any of these two. Fine, now this gives us x times partial derivative of y with respect to y is 1 into phi plus partial derivative of phi is phi dash of x plus 2y plus xz square into inner derivative, that is dou by dou y of x plus 2y plus xz square, right, into y, which gives us q equal to x times 1 into phi is phi, that is phi of x plus 2y plus xz square plus phi dash of x plus 2y plus xz square into partial derivative of x plus partial derivative of 2y plus partial derivative of xz square into this y. Now this gives us q equal to x times phi, that is phi of x plus 2y plus xz square plus phi dash of x plus 2y plus xz square into partial derivative of x with respect to y is 0, since x is treated as constant, because we are partially differentiating with respect to y. So we'll get partial derivative of x with respect to y is 0, plus here 2 is constant, we'll write it as 2 into partial derivative of y, plus here x is treated as constant, again we can write this as x into dou by dou y of z square, okay, into this y, which gives us q equal to x times phi of x plus 2y plus xz square plus phi dash of x plus 2y plus xz square into 2 into partial derivative of x, partial derivative of y with respect to y is 1 plus x into partial derivative of z square with respect to y is 2z into dou z by dou y, right, into this y, okay, which gives us q equal to x times phi of x plus 2y plus xz square plus phi dash of x plus 2y plus xz square into 2 times 1, 2 plus 2x yz into, we'll just replace it by notation q, since we have a notation dou z by dou y equal to q, right, we'll get q here, okay, into this y, right, 2xzq into y. Now this gives us q equal to x phi, x into phi of x plus 2y plus xz square plus x y into phi dash of x plus 2y plus xz square into 2 plus 2xz cube, right? Now bring this term to LHS, you'll get q minus x into phi of x plus 2y plus xz square equal to xy into phi dash of x plus 2y plus xz square into 2 plus 2xz cube. Consider as equation number 3. Now we have equation 2 and equation 3. We'll replace phi using equation 1 and also we'll eliminate 2 and phi dash using 2 by 3. Let's see that. Fine, now we have equation 1, that is z equal to xy into phi of x plus 2y plus xz square, right? Or we can write this as xy into phi of x plus 2y plus xz square equal to z, right? Now take this xy to RHS. Then you will get phi of x plus 2y plus xz square equal to z by xy, right? Now what we'll do is, with the help of this phi, we'll rewrite 2 and 3. 2 becomes p minus y into, here we have phi, right? Replace this phi by z by xy, okay? Equal to xy phi dash of x plus 2y plus x plus z square into 1 plus z square plus 2xzp. Consider as some equation number 4. And 3 becomes q minus x into, replace this phi using z by xy equal to xy into phi dash of x plus 2y plus xz square into 1 plus z square plus 2xzp. Consider as equation 5. Now using 4 by 5, we'll just eliminate this phi, okay? This gives us p minus y of z by xy by q minus x into z by xy equal to LHS of 4 by LHS of 5 equal to RHS of 4 by RHS of 5. See, in equation 3 you have 2 plus 2x plus 2xz cube. I'm sorry. So you'll get 2 plus 2xz cube, right? Where phi dash and xy gets cancelled. This gives us p minus y times z by xy by q minus x times z by xy equal to 1 plus z square plus 2xzp by 2 plus 2xz cube. Okay, fine. Here y and x gets cancelled. Okay, instead of cancelling this, Let's see what happens if we take xy as LCM in the numerator and the denominator as well. We'll get pxy minus yz by xy by qxy minus xz by xy equal to 1 plus z square plus 2xzp by 2 plus 2xz cube. This xy gets cancelled and we'll get pxy minus yz by qxy minus xz equal to 1 plus z square plus 2xzp by 2 plus 2xz cube. Okay, now make a cross multiplication to simplify it. We'll get pxy minus yz into 2 plus 2xz cube equal to qxy minus xz into 1 plus z square plus 2xzp. Right? Take y common from these two terms, you'll get y times px minus z equal to, take x common, you'll get x times qy minus z into 1 plus z square plus 2xzp. You can consider it as partial differential equation or you can simplify it further. Let's see. Now we are going to simplify it. Now let's simplify this equation. We'll get 2 terms into 2. 2pxy minus 2yz plus this term into this term, 2x into x square yz pq minus into plus minus this term into this 2xyz into zz square q, right? 1 2 3 4 terms equal to this into 1, these two terms into 1 gives qxy minus xz plus z square into these two terms qxyz square minus into plus minus xz into z xz cube, okay, plus this term into these two terms 2x into x square y z pq minus into plus minus 2x into x square z square p, right? 1 2 3 4 5 6, right? Fine. Now you can cancel 2x square yz pq from LHS and the RHS. Now what we'll do is we'll write all the terms that involves p in LHS part and the terms that does not involve q or p in the RHS part. So we'll write the terms which does not involve p and q in RHS and the remaining this term, this term, this one and this one. All this 5 comes in LHS part. Okay? Fine. First I'll write 2pxy and minus 2xyz square q because it exists in LHS itself. Now I'll bring this term to LHS. This becomes minus qxy plus qxy square. Qxyz square becomes minus qxyz square minus 2x square z square p becomes plus 2x square z square p, okay, equal to the terms that exist in RHS minus xz minus xz cube. The terms which exist in the RHS which does not involve p and q. Okay, fine. Now we have to take this to RHS, we'll get plus 2yz, right? Fine. Now take 2xp common from these two terms, we'll get 2xp times y plus x z square, right, only xz square. Now take, this 2 gives minus 2xyz square q and minus xyz square q gives minus 3xyz square q, right? And this term minus qxy equal to, take z common from these 3 terms, or you can just write this as 2yz minus xz minus xzq. Now take minus xqy common from these 2 terms. Minus xqy or qxy better. Let's write it as qxy. We'll get minus qxy times 3z square plus 1 equal to, here we can take z common from all these terms, right? You'll get x times 2y minus z minus, here we took z common, right? We'll get z times 2y minus x minus x z square. Again you can take x minus x common from these 2 terms. This gives us, you can write this as 2p times y plus xz square into x minus q times 3z square plus 1 into xy equal to z times 2y minus x times 1 plus z square minus x into 1 minus x minus into plus minus xz square, which is the required partial differential equation. Which is the required partial differential equation. This completes the problem. Okay, fine. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.